So hello everyone, today we are going to start with Catia's next lecture. So till now we have completed all the constraints of assembly as well as the remaining tools that are required for assembly. But today we are going to start with top-down assembly. So we'll start with top-down, say start, mechanical design and assembly design. In assembly design, first we are going to make the part here, then we are going to assemble them one by one. So the first part we are going to make here is flange. We are going to make one simple flange coupling assembly only of 3 parts. So to start with, we are going to make flange first. Now to make a part in assembly, we need to click on this option, that is part in product structure tools. So I'm going to click on this option. Then we need to click on the assembly title, that is this product 1. In model tree, part 1 is going to appear here. So if you need to change the name of this part, we can change it. So we'll right click it here, go on properties. Here we need to change the name. So in part number we are going to provide the name here as flange. Say apply and OK. Now part 1 is appearing as flange. Now to make this part using features, we need to expand the model tree here. At present we are in assembly interface. We are going to double click on this option after expanding on this title name only. And this interface you will see that it will change to part modeling. So I'll double click it here and you will see this command changing. So now we are in part modeling interface. We are going to start with the front plane here. Select this plane. Now one thing more, these planes are not been highlighted here. It is because the appearance of this view parameters is being changed. So I'm going to click on this view toolbar. In that we are going to go for this customize view parameters and select this third option, that is shading with edges. And after that we can see here the planes are being highlighted. We'll shift this view bar at the bottom. Next we are going to start with the front plane. Say sketch. And now we are going to add the features for making flange. The first feature we are going to use here is shaft command. For that we are going to make the sketch first. We are going to use the shaft command. That's why we are going to make half sketch only at one axis side. Provide the values here. Diameter we are going to take the overall diameter as 120. So this value we are going to put here is 60 mm only. This distance we are going to take here as 3 mm. And this inner side diameter we are going to take 110. So I'll take this value here as 55. Next we are going to continue with the profile again. Now we have the complete close profile. So we'll put up some more dimensions here. I'll take this value here as 23 mm. So this inner diameter we are going to take 60. For that this value will be 30 mm. And this total length we are going to take here is 53 mm. Now the complete profile is been made and constrained. We are going to say exit sketch here and go for shaft command. Select the axis, say preview and say OK. Now we need to provide holes and appearance here. For that first we are going to go for appearance option. So for appearance, just right click on the title flange, go for properties option. So for appearance, we are going to click on this part body here under the flange. Say right click and properties. Select the graphic window and say color. We are going to take this color here as blue. Say apply and OK. Now for making holes, we are going to use hole command here. Select the hole command. Select the face on which you want to apply the hole. Now in extension, we are going to provide the diameter. So I'm going to take this diameter as 9 mm. End condition we are going to keep up to last. Next, positioning sketch. So now the hole is appearing at the center of this face. We are going to position it. Select the position sketch. First we'll make one PCD here, pitch circle diameter. So the diameter for PCD we are going to take here is 80 mm. Now we'll place this point on this circle. For that select the point as well as the circle and say relation as coincide. Say OK. Now we need to make this orientation vertical. For that select this point as well as the axis and go for the relation as coincide. Say OK. Diameter we need to change here as 80. Now after positioning this whole point, say exit workbench and the hole will appear here. Say OK and finish. Now we need to go for pattern. Here the total number of holes we are going to take here is 6. For that we are going to make the use of pattern command. We would have directly made these holes by making all the holes together in one sketch only. But after that we would not be able to make patterns in assembly. So for that it is compulsory for us to make these holes by using pattern command only. So total number of holes are 6. We are going to use the circular pattern here. First we need to select the objects to pattern. So here I am going to select this hole. Next I am going to say here as complete cron parameter type. Total number of holes we require are 6. Reference we are going to select this face here and say preview and OK. So now all the holes have been made by the pattern. The original one is at the bottom here, we can see. We need to make one more hole at the center for shaft insertion. Select the hole command, select the face. It will by default come at the center only as it is a circular part. So diameter we are going to take here is 30 mm. And I'll say the end condition as up to last only. Say preview and OK. So now this part is completed, that is flange. Now as it is a top-down assembly, first we are going to go in assembly interface again as we have switched to part modeling. So for that we need to double click on this product title. After double clicking here, the interface will change to assembly here. So I'm going to click on this title, double click it here to change the interface to assembly zone. You can see here all the toolbars are being changed and we are again in the assembly zone. So we are going to go for next part now. Select the same option as part beside the existing component at the left side. Select the part option, select the product title. After clicking on product, one note will appear here asking whether you want to use the same origin that was used for this part 1 or if you want to make the part with new origin, then say no. So I'm going to say a no only as I want the new origin or new plane setup. Now here we can see part 2 has been appearing. I'll change the name here first. Say right click, go on the properties option. Same process as we have done earlier. Here we need to go on this product title. Change the name here as bolt. Say apply and OK. Now after renaming the second part, that is bolt, we'll expand the model tree here. And now we'll click on the subtitle with the same name as bolt. As soon as you click here, you can see the access system has been appearing in orange color. This is nothing but the new access system being overlapped with the previous one. So if I want to move this access system for the new part, I'll click on this compass and move it on this access system and drag it here. So you can see this new access system has been separated from the older one. Place the compass at its place and now we are going to make the second part by using this access system here. Now to enter in the part modeling interface, again click on this subtitle named as bolt and we can see here these toolbars are being changed. We are in the part modeling interface. Now in part modeling interface, you can see all the part modeling tools are been appearing. We'll start with the front plane, making the second part bolt. Say sketch and we'll make one bolt here. For that we are going to make the shaft first by using shaft command. So here the length of the bolt we are going to keep it as 12 mm and the diameter is 9 for the hole. So we are going to take the same diameter for the bolt shaft. The radius for that diameter will be 4.5 mm. Next we are going to say exit sketch, exit workbench and say shaft command. Select the profile, show the axis and say OK. Select the face and say sketch for making the head of the bolt. Now we are going to go for hexagon command in rectangles. We'll shift this toolbar here above. And now we are going to make one hexagon here. Take this line and say relation as vertical. Say OK. Put up the value for the circle. This circle for making the hexagon. So I'm going to take it as 15 mm. I'll say 16 here. Say exit workbench and go for pad command. I'll say 5 mm for the pad. Now we can see one bolt has been made. Now we need to go for the above fillets or chamfers. For that we are going to select the plane which is crossing the maximum distance of this hexagon. So the maximum distance for the hexagon is not in between the sides but in between the corners. So the plane that is passing through corners is this plane, that is front plane. Say sketch for this plane. Zoom out here. And now we are going to make one profile that will be for the fillet on the above head. After that we are going to project these edges here. Select both the edges and say project entities, say construction mode. These are been taken for reference purpose only, these edges. After projecting the edges, we are going to go for arc command. So in arc, we are going to select start end with radius. Now this arc is coming tangent on one side. Provide the tangency on other side also. Provide the radius required. Radius we are going to take here as 1 mm. Now we need to close this sketch. For that we are going to again convert this construction line to solid lines. Select both the lines and put off this option, that is construction geometry. Next we are going to trim these entities again. So in operations toolbar, select quick trim, double click here, and these lines are being trimmed now. This is complete close profile. Say close sketch, exit workbench, and now we are going to go for groove command. Here select the profile, then next we need to select the axis and say preview. Say OK, and we can see here these corners are being filleted now. Next we are going to go for appearance for the bolt also. So here in part body, click on the part body option, go for properties and graphics window, select the color you require for the bolt. I'll select this brown color here, say OK and apply. Now for making other part, first we need to shift to assembly zone again. For that double click on this title product and this interface will be changed to assembly. So I'm going to double click on this product and we can see we are again in the assembly interface. So to start with the other part, we'll repeat the cycle, that is select the part first from product structure tools toolbar, then select the title. It will ask you for the same origin to be used or you want the another origin. If you want new origin, just say no here, and this part we can see part 3 has been appearing here in the model tree. We'll expand it. We'll right click on this part 3, go to properties and provide the name required. Now in properties we need to provide the name here at the downside, say NUT nut and say apply and OK. Next we'll expand this and here in the subtitle also the same name will appear. We'll select it and we can see the axis has been selected. The axis system has been selected. This is the new axis system being overlapped with the previous one, with the first one. So we'll move this axis system to make the new part, or else we can make the part here itself. So first select the title again, this nut, and then keep this compass here. Drag the axis system again. Place this compass system at its previous place and we'll start with the new part. Again for making the new part we need to change the interface to part modeling. So one more time we need to click on this subtitle, double click it here. It will change the interface to part modeling. Now we can see the part modeling tools have been appearing again. So we'll start with the nut. Say this right plane, say sketch. And now we are going to make this nut here. We'll select the hexagon. Go for the size here. We'll take this size here as 16. Same diameter as that was for bolt. Just hide the planes here. Make this sketch normal again. Select this line and go for the relation as vertical. Now sketch is constrained. Now if you want to see whether the sketch is fully constrained or not, you have this toolbar here, that is tools in part modeling. In that toolbar you select this sketch solving status. So select this toolbar and you will see it is showing here this, it is completely constrained. ISO fully constrained. Say close toolbar. Then go for the pad command by exiting the workbench. Next we'll select the plane for making the fillets here. So I'll select the plane again. The plane should be that plane which is crossing the maximum distance. So here this plane, front plane, is crossing the maximum distance of this cross section, that is these two vertex points. Say sketch, select both the edges, say project entities again, go for the 3-point arc, select the first point, the second point and third point. We'll provide the radius now. So I'll say this radius here as 1 mm. Now one side of this arc has been tangent. We'll make the other side also tangent. See the relation here as tangency. And we'll trim the extra parts of the line. Now complete close profile has been made. We are going to say groove. Say exit workbench. Say groove. Select the profile here. show the axis, say preview and say OK. Now we can see these corners are being filleted here. Now we'll mirror this fillet here at the downsides also. For that we are going to take one mid plane. So for mid plane this distance was taken as 5 mm. So for mid plane I need one more plane here at the distance of 2.5. So this plane is coming in between the thickness of this nut. Now for mirroring this feature at the downsides, we are going to use transformation features mirror command. First select the feature you want to mirror. So I'm going to select this groove here. Then select the feature, that is mirror command from transformation features. Here it is asking for the reference element or a plane. So I'm going to select this plane. Say OK. So now this fillet is coming on both the sides. We'll give the appearance for this nut also here. Select the part body and then go for properties. In window we are going to select the color here as green. Say apply and OK. Next we are going to select this face, say sketch, and we are going to make one circle. This will be for pocket command so as to insert the bolt shaft. Select the circle command here. The diameter of bolt was taken as 9, so we'll take this whole diameter also as 9 mm only. Say exit workbench. Next we need to select the pocket feature. Say OK and finish. So after completing this nut, we are going to shift to assembly zone again. For that we are going to click on this product title and now we can see we are in assembly zone. These above toolbars are being changed. Next thing we are going to do here is we need to edit this part and we need to increase the length of the shaft. So to edit this bolt, I'll double click on this bolt title here. And here on this shaft sketch, we are going to double click on this sketch to edit the length. So earlier the length was taken as 12 mm. We are going to increase it and say around 18 mm. Say exit workbench. This part has been updated now. If you want to manually update it, you just need to click on this icon, manual update mode. Now after editing the bolt, we are going to go for the assembly commands. We'll shift to assembly zone here. Double click on product. And now we are going to assemble the parts here. Now as we are seeing the top down assembly, we have completed all the parts. We need to assemble them together. So to start assembly, we'll make this part fix. So fix constraint will be applied here. I'll call the constraint toolbar here first and then we are going to apply the fix component. Just click on this option and click on the part required. The fix constraint is been applied. Next part we are going to assemble here is bolt. So for bolt, I'm going to say coincide constraint first with axis to axis. Before that we need to know which hole was made first and then all the holes which were patterned. For that we are going to expand the model tree of the flange. Here we are going to see the hole first. So as soon as I click on this hole, before pattern, this circular pattern, before that you can see this hole has been highlighted. So we need to assemble this bolt into this hole only. For nut also it is going to be same, that we need to assemble this nut on the first hole only. Then only we can provide the relation with the first hole, and after the first bolt been assembled we are going to go for pattern. So we'll go with the first constraint for the bolt, that is coincide axis. Select the hole which we have seen. I'm going to select the first hole. You can see this hole has been highlighted here. Now the coincide constraint has been applied. Say update here. So here is the icon for update. Just click on this icon, or else you can use the shortcut key as Control U. So it is coincided now. Next we need to say coincide with faces. So for that again coincide made. Select this face and this face. We can go for the other mate also. Instead of coincide we can take this contact constraint also. Contact constraint is only used when the mates are to be applied on two opposite faces. Means the faces orientation are to be opposite, then only we can use this contact constraint. Contact constraint. Say update. Next we need to log the rotation of this bolt. Now if I want to see the degrees of freedom for the bolt, right click and below the delete option there is one option with the same name as part. Go to component degrees of freedom. So here we can see rotation is on. So to lock this rotation we are going to use this angle constraint here, and within angle constraint there are three constraints: parallel, perpendicular and angular. We can apply any constraint out of three so that the part will not rotate here. I select the constraint. We are going to select this plane here and the plane of the first part, that is of flange. We are going to say both the planes as parallel. I'll say on the same side, say OK. Now the rotation of this part has been locked. We can cross check here. Right click, say degrees of freedom, and here you can see there is no degree of freedom. Next, we are going to go for pattern command now. So for pattern, we have this toolbar in constraint, that is reuse pattern. Select the bolt and select the pattern from the model tree. The pattern was made in flange part, so I'm going to expand this flange part and then select the pattern which was applied in part modeling here. So we are using the pattern which was made in part modeling itself. That's why the name of this command is reuse pattern. If you have not made this pattern in part modeling, you are not able to apply the pattern in assembly also. The first step was to select part, second was to select the pattern from the model tree, and the third step is to say generate constraint. Only three steps are required, say apply and OK. So except first one, we are going to see any random bolt here, say this 6 number. If I go on degrees of freedom, for that we can see there is no degree of freedom being shown. So now this part is completely and fully constrained here. Now next we need to establish the relation of this nut also with this same hole. That was this hole, the first hole. You can see here it has been highlighted in orange color. If I need to pattern this nut also in 6 numbers, for that again we need to make the constraint with the hole only, not with the bolt. But if I go for coincide constraint and try to select the axis of the hole, so to avoid this problem, we need to hide all the bolts here. So I'm going to go for hide command for the bolt. Select the first bolt, say right click and say hide. Now this first bolt has been hidden here. We are going to apply the made constraint now. As the bolt is highlighted, only axis of this hole will be shown, and that axis will be used to coincide with the nut, making the relation directly between the hole and nut. That is important need for the pattern. So select the axis of hole now and the axis of the nut. Say update, coincide constraint has been applied. After maintaining the relation with the hole for the nut as coincide, now we can unhide the bolt. Next constraint we are going to go for contact constraint. So in contact constraint I am going to select this flat face of the nut and the flat face at back side of the flange. Say update. We can see here this nut is also been placed here. But now to lock the rotation, we need to apply a relation between the planes of nut and planes of main assembly, making them parallel or perpendicular. Or else we can go for angle also. Say parallel, say OK on same sides. And now the nut rotation is also been locked here. Just right click and see degrees of freedom whether they are locked. Yes, it is showing now there is no degree of freedom. Means this nut is also been fully constrained now. Next we are going to pattern this nut and the assembly will be finished here. So reuse pattern again. We need to select the part, that is the first step. Then we need to select the pattern which was made in flange. Expand the model tree and select that pattern which was made in part modeling. Then we need to select the option that is generate constraint. Now this flange coupling assembly has been completed. Now one more thing, we need to hide the planes of this part here. For that select the view tab, and in view tab we need to go on this option shading with material. Go for this last option here with the question mark, customize, and say no access, so the planes will be hidden there. We can see no planes are being shown now, and this simple assembly of flange coupling has been completed by the use of top-down assembly. Now the last part is to save the assembly. So as soon as you click on this save option, this assembly will be saved separately and the parts will be saved separately. So we'll see whether all the parts and assembly are been saved into single folder or not. So we'll go on files in D drive, Catia V5 R21. Here was the folder been made, and now we can see all the parts are separately been saved even if they are made in assembly interface only by using top down. After that also this part are been saved separately and the assembly is been separately saved. You can see the title showing as Catia product. So this was Catia assembly by using top down method. For understanding the assemblies of Catia in deep, you can join the courses also. The contact number in the link will be given below. You can contact us for placements in mechanical design on software such as AutoCAD, SolidWorks, Catia, BIW design, fixture design. or else you can visit the website also 4di.in to know more. So for today, this was the lecture. We'll continue for the further commands in next lecture. And now from the next lecture, we are going to start with surfacing. So stay tuned, subscribe the channel, follow the playlist of Catia. Till then, thank you.